Hey, in this video, we're actually going to set up our reduced or refined model lab, and we're going to delete those problematic observations that we just talked about in the previous video. So the first step in this process is to add a new worksheet. See if I can find my cursor. Add a new worksheet. Okay, so right now I'm clicked in my full model lab worksheet. I'm going to click on the plus sign down here to add a new worksheet. And we're going to rename this. You can rename it reduced model, you can rename it refined model. I think in the instructions it says to rename it refined model. Ultimately, we're doing both of those things. We're reducing and refining the model. And then we'll give it that lab suffix or lab label so that we can make sure that we keep this distinctly different from our homework. Okay, the next thing is we do need to copy the data from our full model into our refined model. Okay, but before that, we have to create an observation row column. Okay, so there's a couple ways we can do this. We can go to our full model lab. We can find this observation column right here, copy those values, and then paste them in column A right here. Okay, so again, all I did was go to the full model lab, copied the list of observation numbers from this residual output here, and then pasted them in the refined model lab worksheet in column A. Alternatively, you could just label it observation and number the observations 1 through 1521. Okay, then we're going to come over here and we're going to grab our data set from our full model worksheet. So on my full model lab worksheet, copy that data, take it over to the refined model lab worksheet, and we'll paste the data right next to it. Okay, I'm just going to format paint column A so it looks consistent with everything else. Okay, now in our case, the observation and the house ID match up. Okay, that's because when you got your clean data set, your house ID variable was renumbered 1 to 1521. If we had not done that, these numbers would not match up. So I don't want you to get in the habit of using ID as the comparison for observation number, which is why we copied those. Just note, in this case, they are the same. In practice, they might not likely be the same. So now we have our data set up. We don't need to remove any of our independent predictors. We know that they're all adding useful information. If we did, we would go ahead and delete them from our refined model lab worksheet before rerunning the model. Okay, so the next step, go to our full model lab, okay, and we have to identify those problematic outlier values. So I mentioned if you actually just hover over those points on the plot, you can see that the second point, the second value in that little tooltip below your cursor is the residual value. So it's saying that this data point right here, this prediction, has a residual value of negative 16.2. So that's how much we were off in our prediction. Okay, that means that we predicted it to be more than it actually sold for. Same thing here, if you hover over it, we can see that has residual value of negative 10.68. This one, residual value of negative 12.2. Okay, now if we hover over those same points, they are the same exact residual values. The good news, we can even go to our normal probability plot. Okay, the good news is that these are all the same 4 values. They correspond to just only 4 observations out of the 1521 observations in our data. So the way that we identify which observation number are associated with those residual values is we first have to sort these residual values from smallest to largest or least to greatest. Okay, when we do that, don't worry about your plots over here. They're going to get jumbled up for a second until we resort by observation number. But what I want you to notice is that those 3 observations on the bottom side that were flagged, those observations that had a residual of being less than negative 10 are identified here. It's 234, it's 1019, it's 1020, also the same observations. So if you wanted to, you could just color code them in red so you know maybe jot them down, those observation numbers down, because we're going to have to remove them from our refined model data set. Okay, now to identify the residuals that have high positive values, we're going to resort these residuals from largest to smallest, and we can see that there's one residual value, it's kind of borderline, that's more than 10. So I chose this threshold of 10 and -10 because that's where, in general, a lot of the data stopped. You can be a little bit more restrictive and say, okay, I'm going to remove everything that's greater than 9 or 8.5 or 8. You know, you can kind of make those decisions, but you want to find a balance between not overcorrecting the sample data so that it no longer reflects the general population. So I'd like to be a little bit more conservative. Think about it like a haircut. You know, we can trim more and more off if we need to, but after we delete them, it's harder to reverse the process. So, so we know now that those observations that we need to remove, they're 46. And then if we resort 234, 1019, and 1020. So that was 46, 234, 1019, and 1020. Okay, and again, these are also highlighted for you in that lab PowerPoint. So before I go any further, I do want to resort this by observation number just to make sure that my residual plots over here go back to the way that they should be represented. Okay. Well, that doesn't look quite right. We won't worry about that for in this second right now. Okay, that's better. I think these are the same values now. Okay. Just want to make sure that everything goes back to looking the way that it should. Okay, there we go. All right, so now our residual plots are back in order. We can proceed forward. All right, so we go to this refined model lab. Okay, and a quick way to delete these observations, you can go through and do them one by one, kind of sort down through, and then just once you find, you know, observation number 46 here, highlight that and then come click delete. The other way that we can do it if we want to do it all at once is put filter buttons on our data set. Okay, we're going to sort this, or not sort it, we're going to click on the little filter button for observation, and then we're going to uncheck select all, and then we'll just check those observation numbers that we identified in the previous step. So 40 was 46, it was 234, it was 1019, oh, passed it. Okay, so 1019 here and 1020. Okay, so when we filter down, we can see those observations. You can compare this to that picture on the lab slide, and then all we would need to do is highlight these, come over here and click the delete button, and then we could remove that observation filter. Now, we know we had 1,521 observations, but we had 1,522 rows originally because we have this first row of labels. So if we had originally 1,522 rows of information and we just removed 4 of them, when we go down, we should see we have 1,518 rows. And this is one way we can check to make sure that those observations were removed. Okay, and then the other check that you could do is to sort through. Okay, we know we removed 1019 and 1020. Now when we look here, we can see 1019 and 1020 on. So you can go back through and just confirm, okay, yeah, a couple different ways I did actually reduce the data properly. Okay, so that's all for this second part of this video. In the next video, we're going to build our refined model. We're going to perform those assessments that we did just like in the full model, and then we'll use that model to make a prediction.